Almost every major car maker now sells a hybrid vehicle, which combines electric and combustion power. Some are now making fully electric cars. And deep in the battery-based hearts of these vehicles, chemical reactions are giving them their juice. Electric vehicles, whether hybrids or fully electric, use a battery and a motor to go. The battery is like the fuel tank, the electric current is the gas, and the motor is the engine, where electrical energy turns into mechanical energy to make the wheels spin. You can think of electricity as the transfer of electrons between atoms of matter. When electrons move from atom to atom, a current of electricity is created. Most hybrid and electric vehicles use rechargeable lithium-ion batteries, like the batteries in a smartphone or a laptop, as the source for generating electricity. Inside that battery, the anode and the cathode sandwich a conductive electrolyte. Electrolytes are solutions that can conduct electricity because they contain dissolved ions. Positively charged lithium ions move back and forth between the electrodes to charge and discharge the battery, while electrons flow to the motor to power the car. The anode is made of graphite, which has stacked sheets of carbon atoms. When the battery is fully charged, neutral lithium atoms fill the spaces between these sheets. When the car draws electrical energy from the battery in the form of negatively charged electrons, positively charged lithium ions move across the electrolyte from the anode to the cathode, which is made from lithium, metal, and oxygen. Like the graphite in the anode, a lithium metal oxide, like lithium cobalt oxide for example, forms sheets that neutral lithium atoms can fit between in the cathode of the battery. The compounds used in the electrodes affect how quickly the battery charges and discharges, and engineers choose which ones to use so they get the battery performance they're looking for. Electrons from the graphite anode meet the positive lithium ions at the lithium metal oxide cathode, but they don't flow through the electrolyte like the ions. They take a different route, delivering electrical energy to the motor. When the anode loses electrons, that reaction is called oxidation. On the other side, when the cathode gains electrons and positively charged lithium ions, that's called reduction. When the battery is being charged, the reactions and the flow of lithium ions are reversed, sending electrons and lithium from the cathode back to the graphite anode to wait for the next discharge. In this way, the batteries inside hybrid and electric vehicles are rechargeable. The chemical reactions they use to power the car can be reversed, so they can repeat this process many times before they have to be replaced. Inside the electric motor, a rotor spins inside or around a ring of electromagnets. When electrical energy from the battery flows to those electromagnets, the forces of attraction and repulsion between the magnets and the rotor make the rotor spin. That spinning is transferred to the wheels by gears and shafts, making your car go. One especially cool thing about electric and hybrid cars is that an electric motor can also be an electric generator. So when there's no electrical energy flowing to the magnets, spinning the rotor will convert mechanical energy into electrical energy in the magnets. If you're coasting in a car with an electric motor, the car's momentum can spin the rotor inside of it, sending electrical energy back to the battery to recharge it. So when you hit the brakes, the electric motor actually goes into reverse, helping slow the car but also sending energy back to the battery to charge it. This is called regenerative braking. For comparison, in an internal combustion vehicle, a coasting or braking car's energy turns into heat through friction and can't be put to further use. As the engineering that propels them becomes more advanced, electric and hybrid cars seem poised to become even more commonplace than they are today. But regardless of whether a car is powered by a combustion engine, an electrical engine, or a hybrid engine, it won't get you where you're going without chemical reactions.